Welcome to this edition of Gary Wybenga Teaches. In this episode, Gary teaches us about the Vanishing Zone, whatever that is. Apparently, the Vanishing Zone has something to do with the bottom parts of distant objects disappearing before the top parts do. It seems there is some angle involving the surface of water between the observer and the bottom of the object being observed that becomes so narrow that the light from the bottom of objects simply ceases to exist. I don't know how this is supposed to work, but maybe Gary can explain it.
This is a clip out of Jose's show today. That line moving up, pointing up, is a mast of a sailboat. You see people here on a walkway. Now the walkway with the people is much closer than the mast of the sailboat, which is much further away. Now their big question is, why can't they see the bottom of the boat? And of course, they'll say curvature, which is a complete crock of shit. This image that you're looking at is from a P1000 zoomed in. He could not see those people or that mast of that sailboat without the P1000. With just his natural eyes, they weren't there. Now, is that because there was a hump of water in the way? No. It's because with your eyes, the angle is insufficient to resolve what's compressed into that angle. Now, that angle can change several ways. One is by going up an elevation, which would widen the angle over the water, which would allow you to see the bottom of the sailboat and water beyond. And the people would actually look more clear. When you zoom in, you increase the focal length, you decrease your field of view. What he's looking at in this picture is a very tiny piece of his entire field of view that he's looking at with his natural eye, as we're going to see in a minute when he backs off the zoom. I put it in slow motion so you can see what's happening. He's going to back off the zoom, and you're going to watch everything compress back towards center frame. You will no longer see the people. You will no longer see the mast of the sailboat. Another boat will come into the picture here in a minute on the right-hand side of the picture. It will become super small. Right now, you see it happening. Where is everything moving towards? Center of center frame. So those people, when it was zoomed in, appeared above the horizon. But as you can see, they're compressing into that horizon. So everything from the sides is moving in towards center, from the top moving down into center, from the bottom moving up towards center. It's compressing into that field of view. He's decreasing the focal length, which is increasing his field of view. As you can see now, it was a tiny portion he was focused in on. When you zoom in, you also dedicate all the pixel space then for the picture because it's focused on just a little tiny area. So all the people have become unresolvable. The sailboat beyond unresolvable. Even the big boat that was to the right that first came into the picture is gradually becoming unresolvable, bottom first. As they compress, it will still remain slightly visible. It's close enough. So, are the people and the sailboat mast beyond a hump of curved water? No. It's simply the angle is insufficient for the natural eye. The zoom lets you see a little more, but it reached a limit also. Maybe someday they invent a P2000. You see more. But another simple way of doing this would just be go up an elevation, which would open up your field of view to a deeper depth of distance, which would allow you not only to see the people, you would see them more clearly, and you would see the bottom of the sailboat beyond and water beyond that.
But wait, Gary didn't mention the Vanishing Zone even once in that clip. According to the title of his video, the Vanishing Zone is an optical limit of perspective compression in your field of view. But what does that even mean? Gary didn't bother to explain what he was talking about. Maybe Gary just wanted to sound smart. Gary did mention something about an angle that is insufficient to resolve what's compressed into that angle. What angle is Gary talking about that compresses the image from the bottom up? Gary could be referring to the angle of view, which is the angle subtended by opposite edges of the image, for example, top and bottom. This angle does get narrower with distance, but it does not cause objects to vanish from the bottom up, nor into the center of the frame. And the angle of view is not measured from the surface. Perhaps Gary was talking about the angle between the observer's line of sight to the bottom of the object and the surface. Of course, that angle has nothing at all to do with the things we see in the distance. Even when the angle does get larger with altitude, there is absolutely no reason that it should make objects clearer nor increase their angular size. So what angle does cause the optical limit of perspective compression? And what is the vanishing zone? Let's see what else Gary Wybenga has to teach us.
This kind of represents how we see things in our field of view. Our field of view is the largest determiner of how we see things based on the angle to center frame. Everything moves towards center frame as things move away. So that is the main thing of how you see things. The next thing is angles from objects subtended to your eyes. That places them in their proper places within your field of view. Here we have a lighthouse. We have the land underneath it. This is a zoomed in image. It's going to back off the zoom, and you're going to watch all of that compress bottom first and become unresolvable bottom first as it compresses towards center frame. Your vanishing zone, the black hole of information. I'm going to play it back in slow motion so you can observe and see for yourself. Nobody can complain that this isn't a clear image. This is very clear. You're going to watch all kinds of information disappear. See the looks like a buoy. That'll disappear. Well, the information is compressing with distance. As you back off the zoom, it's no longer magnified. The problem with the zoom is people are fooled because they think, ooh, how can that big thing be hidden? Well, it's not hidden. It's just unresolvable. When you zoom in, you magnify the image. Now you see the red portion at the bottom of this boat. There's also going to be some turbines in here, yellow bottoms. Now the zoom is backing off. The ship is approximately 11 or 12 miles away. Turbines are closer, but still far away. Now you watch the yellow portions are becoming unresolvable as separate, and the bottom of the boat before the tops. That's angular compression and Rayleigh criterion as things vanish into the vanishing zone, the black hole of information. Here you're going to see just a simple angle change. Compress the image. You saw the lettering. All he did was dropped down in elevation from 30 meters to just by the water. Compress the letters. You can see a red space above the letters and below the letters in both images where it's compressed or where it's not compressed. You can see that. All it is compression. Simple angle change, nothing else. Here I want you to pay attention again to the red portions at the bottom of those boats. Also pay attention to that white portion you can see on the dock. Watch as they compress. He's going to back off the zoom. Once again, a very clear picture. Here he's backing off the zoom. Everything's compressing towards center. The vanishing zone black hole is swallowing up that information. You can no longer see the red portions at the bottoms of those ships. The whole image is compressing into a smaller and smaller area. Watch what happens to the bottom of this boat. Everything's moving towards center. The bottom is compressing towards the surface. The information is becoming unresolvable. And all the information is being gobbled up in the black hole of the vanishing zone. You see what happens? The zoom only reveals what's actually happening if you pay attention. Especially when you play it back in slow motion like I did. The vanishing zone is a very real place. Angular compression and Rayleigh criterion are real things. Narrow angles compress information into smaller and smaller spaces as things move away from the observer. It's that simple. There's two things. There's angles from objects subtended to your eyes that become narrower and narrower with distance, and that vanishing zone has a limit. The depth of field is limited by elevation above the surface. The closer you are to the surface, if you're standing on the beach here, the shallower the depth of field will be. The higher in elevation, the more depth of field. That's why when you have a boat that seems to be half hidden when you zoom in, is just too far past the angle for the whatever you're using to resolve it, whatever camera or telescope.
I believe we found it. Gary named the center of the frame the Vanishing Zone. Gary says this is the black hole of information. He presumes that as we zoom out the camera, it's the same as if we were actually getting further from an object. Gary professes that as we increase our distance, everything compresses towards the center of the frame, and he showed several examples in which a highly magnified field of view is zoomed out. In each example, as the camera zooms out, every image does indeed diminish in size, including the spaces between objects. This creates the illusion that everything is getting closer together. But are they moving into the black hole of information? Do they compress to the center of the frame and become irresolvable from the bottom first? I've laid a reticle similar to the one Gary drew on a sheet of paper with his crayon, marking precisely where the center frame is at every moment. Let's watch this as it happens. Gary Wybenga teaches us that the lighthouse should disappear from the bottom up into the center of the reticle. The vanishing zone was clearly above the horizon much of the time, and yet the lighthouse still became irresolvable without moving into the black hole of information, and it did not disappear from the bottom up. Maybe we'll have more success with the next example. The red part of the boat is wider but shorter than the white part above it. While every part of the boat is getting smaller proportionately, the red part is becoming unresolvable more quickly merely because it happens to be thinner. Still, nothing disappeared from the bottom up, nor did anything compress into the center of the frame, as Gary teaches us. So what is actually going on here? As Gary correctly asserts, when the camera zooms out, the field of view increases, and as this happens, the angular size of every part of the image decreases proportionately, including the spaces between objects. This creates the illusion that everything is shrinking or compressing into the distance. Of course, nothing compresses into the center of the frame, nor does the bottom of the image vanish more rapidly than the top, left, or right as the angular size diminishes. This is why we did not see anything disappear from the bottom up, nor move into the reticle at the center of the frame as the magnification was reduced. In fact, the actual distance between the observer and the objects in the field of view did not change in any of the examples Gary showed us. Only the magnification changed. Gary was fooled by the optical illusion created by the telephoto lens. Eventually, the smallest images in the field of view do become irresolvable, yet they don't actually vanish. The light coming from the object is still there, as we can see when the image is magnified, but the light is blended with a new light from the expanded field of view, and thus the image is lost in the cacophony of light rays. Naturally, the Rayleigh criterion, which does not even kick in until the angular size gets below about 500 nanometers, has nothing to do with the object becoming irresolvable, nor the bottom of the image disappearing first. In fact, the bottom of the image does not disappear before the rest of the image due to the optical limit of perspective compression. Nothing actually compresses. Nothing moves into the black hole of information. Gary simply made up the vanishing zone. Clearly, Gary does not understand these simple facts, which explains why he invents magical imaginary concepts and foists them on us as the accepted science of reality. Gary understands cows. He can train us how to feed a herd, how to milk a herd, how to shovel the fecal matter, but he cannot train us in a topic for which he has no understanding. Of course, the fact that there is no such thing as the vanishing zone, nor the black hole of information, will not keep Gary from teaching it to us. Thank you for watching, and if you like this video, please hit the like button and comment below. Remember to subscribe and click the bell to receive notifications when the next Gary Wybenga Teaches video is released.